Hello, this is Dr. Amudapriya, Associate Professor Triply, Rohini College of Engineering and Technology, Palkuda. We are discussing about the course Power System Analysis, where we are going to discuss the power flow analysis in a fast decoupled method. This is the third method for the analysis purpose. Here, we consider the Jacobian matrix J2 and J3 to be, the J2 and J3 component of the Jacobian matrix are considered to be 0. So obviously it is del P del Q is equal to J1 0 0 J4 del V. Here we can calculate the value of del P and del Q, and then obviously we can find out the ratio of del P by del Vi and del Q by del Vi, where we can also find out the del and the del V value with this. So in this manner we can calculate for the fast decoupled method. Here, as per the iterative method, this method requires more number of iteration than the Newton-Raphson method, but less time per iteration. So it is very useful for the contingency analysis. While comparing the iterative methods, regarding the Gauss-Seidel method, the computer memory requirement is very less. The computation time per iteration is also less. It requires less number of arithmetic operations to complete an iteration and ease in programming. Number of iterations are more for convergence, and the rate of convergence is low. Actually, it is a linear convergence. It consists of its characteristic is of linear in nature, the convergences, and the number of iterations increases with the increase of number of buses, obviously. While considering the Newton-Raphson method, superior convergence is because of the quadratic convergence. It has an 1:8 iteration ratio compared to Gauss-Seidel method. So the accuracy is very high, and the smaller number of iterations, and so it can be used for larger sized systems also, not like GS method. Also it is very faster, and the number of iterations is independent of the number of buses. The technique is difficult, and the calculations involved in each iteration are more, because the matrices itself will have more number of calculations, and thus computation time per iteration is larger. The computer memory requirement is also large, as the elements of the Jacobian matrix are to be computed in each iteration. Moreover, the programming logic is more complex in the Newton-Raphson method. The Jacobian matrix itself will be a complex one. And next, regarding the fast decoupled method, when compared to both the methods, it is simple, and computationally it is highly efficient. The storage of Jacobian matrix elements are 60% only, because we are eliminating two elements, and the computation time per iteration is also less. Convergence will be geometric, not linear or non-linear. It is geometric, that is 2 to 5 iterations required for accurate solutions. Hence the speed of iteration is 5 times that of Newton-Raphson method and 2 to 3 times of the Gauss-Seidel method. So the fast decoupled method is proved to be a better one when compared to those two methods. Those methods are also possessing their own advantages when compared to the fast decoupled method, but for a quick response you can use a fast decoupled method to a greater extent. Thank you.